So we've written down the ionic equation for the reaction between potassium manganate 7 and acidified potassium dichromate, acidified hydrogen peroxide, 2MnO minus O4 minus plus 6H plus 5H2O2 RO2 Mn2 plus 8H4 plus 5O2. Now what we need to do is find the moles of MnO4 minus. We do that because we know this much of potassium manganate and this much, so it's going to be 0.020 times by 35.8 divided by 1000, because remember moles, we're going to use the other formula, moles is equal to concentration times by volume. So if we do that, we get 7.17 times by 10 to the power minus 4. That's the moles of MnO4 minus. Now we've got the moles of this. Well, we want the moles of H2O2, right? So 3 to find out the moles of H2O2, it's a 2 to 5 molar ratio. So we're going to times 7.17 times by 10 to the power minus 4 times it by 2.5, and therefore get the moles of hydrogen peroxide, which will give us 1.793 times by 10 to the power minus 3. That is the moles of H2O2. Now we've got the moles of this, we can quite easily find out the concentration. We know moles equal concentration times by volume, therefore concentration is equal to moles divided by volume. So it's going to be moles, which is 1.793 of hydrogen peroxide times by 10 to the power minus 3 over the volume. We know 25 centimeters cubed of dilute hair bleach acidified with dilute sulfuric acid, and this acidified sample is titrated with potassium manganate, so it's going to be 24 times by 10 to the power minus 3, or 24 divided by 1000, and then you get the concentration to be 0.0717 mol per dm minus cube. However, if you read the question, it says calculate concentration of hydrogen peroxide in the original hair bleach solution, and it says here that the concentration of hydrogen peroxide in diluted solution is 5% in the original solution. So we've just calculated the concentration of hydrogen peroxide in the diluted solution, because remember we did this quick sample with the diluted hair bleach solution. So if we want to get the original solution, well, it's 5%, so we want the 100%, so we're going to need to times by 20, times that by 20, and you get 0.0717 times by 20, 1.43 mol per dm minus cubed. 3.2, state why indicator is not added in this titration. Because the solution, well actually KMN MnO4 is no longer decolorized at endpoint, hence no indicator. Hence an indicator is not added in the titration because KMnO4 is no longer decolorized. KMnO4 no longer decolorized at endpoint, hence no need for indicator. It's not added in titration. 3.3 says give the oxidation state of oxygen and hydrogen peroxide. Well, hydrogen peroxide H2O2. Let's double check that. Yeah, H2O2. There we go. It tells us there. Well, hydrogen is going to have a +2. It's going to be +2. Therefore, oxygen must be -2. O2 must be -2. However, because we've got 2, that therefore the actual individual O is going to have an oxidation state of -1. So that's the only trick. Like, it's not -2. That's for 2 oxygen atoms. The oxidation state of 1 oxygen is -1. Hydrogen peroxide decomposes to form water and oxygen. Given the equation for this reaction, calculate the amount in moles of hydrogen peroxide that will be needed to produce 185 centimeters cubed of oxygen gas at this 100 kilopascals and 298 Kelvin. Gas constant R is 8.31 joules. K to power -1 mole to power -1. Well, the equation hydrogen peroxide H2O2 decomposes. But that's a different equation, that's a half equation. Decomposes to form water, H2O, plus O2. And we know that, we've got 2 hydrogens here, 3 oxygens here on the right hand side. So we need to balance out the oxygens. I'm joking. So we need to balance out the oxygens, and the only way to do that is if we put 2 here, we get 4 oxygens, and then we put 2 here, we've got 4 hydrogens, 4 hydrogens, 4 oxygens, 4 oxygens. Okay, that is the hard part in my opinion. 2H2O2, arrow 2H2O plus O2, because the other one, now the second part is just PV equals nRT. We want to find out the moles of hydrogen peroxide that we need to produce this much of oxygen gas, 100 kilopascals, 290 Kelvin. However, we can't work out the moles of hydrogen peroxide directly because we don't have the volume of hydrogen peroxide, we don't have the pressure, we don't have the temperature. This is for oxygen gas. So we're going to find out the moles of oxygen gas. Ideal gas equation, PV equals nRT. N is equal to PV over RT. No, excuse me, the P should definitely be smaller, but I guess it's fine. So, number of moles, in this case of O2, oxygen, it's going to be pressure in pascals, so 100,000 pascals, or not 100 kilopascals, 100,000 pascals, times by volume. Well, this is in centimeters cubed, we don't want it in centimeters cubed, we want it in meters cubed. We want it in meters cubed. Remember, volume is measured in meters cubed in ideal gas equation, PV equals nRT. So we're going to divide by million, 185 times by 10 to the power -6 over R, which is 8.31, times by T, which is temperature in Kelvin, which is 298. Now this will give us the moles of O2. So number of moles of O2 equals 7.47 times by 10 to power minus 3. Now don't be disheartened by that and say, that can't be right. We're not done yet, because now we're trying to find the moles of hydrogen peroxide, and we know it's a 1 to 2 mole ratio. Look, there's a 1 there, imaginary 1 there, because there's none here, but if there was 1 it'd be the same, and here's a 2. So if we're trying to find the moles of hydrogen peroxide, we're going to have to multiply this by 2. So N, the number of moles of H2O2, equals this times by 2. Probably should write it all out, but you get the point. So 7.47 times by 10 to power minus 3 times by 2. And we get 0.01494, and yeah, so we can say 0.0149 moles, 0.0149 moles, and that is 5 marker. So 2H2O2 arrow, 2H2O plus O2, and then PV of NRT, find out moles of oxygen. You know, make sure you know the units. The hardest part for these questions is knowing, oh, that temperature or the pressure or the volume is not in the correct units, and converting into correct units. And then you can find the moles of hydrogen peroxide by times it by 2. And if you use the correct units, you should get 0.0149 mole, the correct answer. And then the final part of 3.5, final part of question 3.5. Define the term mean bond enthalpy. Mean bond enthalpy is enthalpy change to break 1 mole of bonds in gaseous state. Not necessary, but you could say it. In gaseous state, average over a range of compounds. And that is, I think, for 2 marks. Yes, for 2 marks. And the final other part is for 3 marks. Use the equation in the data in table 3 to calculate value for the OO bond enthalpy in hydrogen peroxide. Well, we know it's going to be energy required to break bonds. So we know it's going to be delta H equals energy. Obviously there's different variations, you could say wherever, but as long as you know what you like, which one you're taking from which. Energy required to break bonds minus energy released when new bonds are formed. So you know delta H is minus 789. Minus 789 equals energy required to break bonds. So this whole thing minus energy released when new bonds are formed minus this whole thing. So with this thing, we've got how many NH bonds have we got? We've got 1, 2, 3, 4, and we've got 1 NN bond. So it's going to be NH 388 times by 4, 388 times by 4 plus an NN, which is 163, plus 163 plus this thing, well, think about it. If we just put brackets around this, we've got one OH, another OH, and an OO. And this 2 just means we multiply it by 2. So we've got one here, one here. That gives me 2 OHs. But because we've got a 2 on the outside, now it's 4 OH. So it's going to be 4 times by 463. 4 times by 463. And that's the hard part, really. Understanding what to do with this 2. Just multiplying this. I put brackets around and multiplying by 2 to get 4 OHs. So 4 times by 463 plus 2x, or plus 200, minus energy released when new bonds are formed, n triple bond n, 944 plus, same here again, put brackets around, we've got an OH, so we've got 2 OHs, but we've got 4 on the outside, therefore it becomes 8 OH bonds. So it's going to be 8 times by 463 plus 8 times by 463. And now the hard part here is not calculating it wrong. So 388 times by 4, 1552. Answer plus 163, 1715. 1715 plus 4 times by 463 plus 1852 plus 2 of the oxygen bonds we're trying to find. We can say 2y, 2e, 2x, curly x is what we want to say, minus, well, 8 times by 463 is 3704. Answer plus 944, 4648. So minus 4648. What we've done is collected terms, and now we can say minus 789 is equal to 1715 plus 1852, 3567 minus 4648. So we get 200 minus 1081. 200 equals, we'll add 1081 minus 789 plus 1081, 292. Therefore, 00 is going to be equal to 292 divided by 2, which is 146. And therefore, the bond enthalpy for the OO bond, not 200 bond, OO bond is going to be 146. That is the end of question 3.